Hello and welcome to this demonstration video by Waylay and Cybus. My name is Josh. I work at Waylay, who offers an automation and orchestration platform, and I'm very happy to introduce today our joint partnership with Cybus. Over to you, Danny.
Thanks, Josh. And hi from my side as well. I'm Danny Rybakowski from Cybus, and we are specializing at Cybus in connectivity and architectures for smart factories. And now I'm very happy to do together this deep dive into the joint demonstration we prepared for you. So, Josh and I are going to show you 3 different use cases which we can realize inside the factory. First, we want to show you how we can bring transparency into the shop floor of a customer. Secondly, we want to show you how we can actually predict critical levels of a coolant to make sure that the workers can always react in time whenever the machine is about to run out of the coolant. And thirdly, we want to show you how we could realize a service level agreement based on actual machine data. For all of those 3 use cases, we're going to leverage the same setup. We have 2 different machines. In the first step, we're going to show you how we can connect an older milling machine which uses a Modbus TCP standard, and we will connect this machine to the Cybus Connectware Edge platform. We will then go ahead and do the same for a modern machine which uses the OPC UA standard. Inside the Cybus Connectware, we're going to normalize all of the machine data and create a common information model. From there, we will make the data available in MQTT for the Waylay Automation Platform. In Waylay, Josh is going to show you how we can visualize all of the machine data and create a dashboard. He as well is going to show you how we can create the business logic and the workflows we need for our use cases. So let's start by connecting the machines. This is the home screen of the Cybus Connectware, where we can find, for example, the license we use, what services are installed already, and if we are connected to the internet or if we're running completely offline, for example. On the left side here, we can see the UI of the Cybus Connectware. We distinguish between services and resources. One service is made out of different resources. For example, a container, a connection, and some data endpoints. We have as well a user management in place and a service catalog for easier access to all the services. In the Data Explorer, we can explore the data trees and branches we just built, and the workbench is there for easier and fast prototyping of services. For our use cases, we have to start at the service catalog right here. We distinguish between northbound and southbound connectivity, and all the services underneath here are available for the Waylay license. In our use case, we first want to connect an older machine which uses the Modbus TCP protocol. We simply click on Install, and now we have the area ID and the machine ID. In the area ID, we create the main data topic. We want all the machine data from both machines to be published in the same data topic. This is the data topic to which we will later subscribe to with the Waylay service. We can give it any random name we like. Let's call it Shop Floor A. The machine ID should be as well unique and refer directly to the machine. Let's call it, for example, Milling Machine 101. Before we can enable the service, the connector will always ask us first for permission if the following resources can be installed. That way, the user always stays in control of his data. The service is now enabled, and we can see all the resources we just deployed. If we click on endpoints, we can see the 5 different data endpoints we are subscribing to for our use cases. The machine protocol is Modbus, and we normalize it into MQTT. On the right side, we could apply some rules to modify the streaming data. Very typical examples here are unit conversions or labeling of data. We can take a look into the streaming data in the Explorer. It shows us the data tree and branches we just built with the service. The incoming data can be found as well here in the bottom. So how are we actually configuring a service from scratch? At Cybus, we focus on enabling the user as much as possible. That's why we have an open documentation and step-by-step guides. We can find it in the service descriptions. We select the Modbus service, and on the right side, we find the links to the connector documentation and Cybus Learn. You can find the documentation at docs.cybus.io. It contains detailed description about all the features and services we have inside the Connectware. The documentation is regularly updated with every software release we do. To find details about protocols, we go to Industry Protocol Details and select Modbus TCP. Users can find here information about the protocol itself, as well as an example configuration file. For more hands-on information, we need to go to Cybus Learn. On Cybus Learn, you can find step-by-step integration guides for the Connectware, as well as general Learn articles. In our case, we want to connect to a Modbus server. We can simply search for the right keyword and find the article we need. How to connect and integrate a Modbus TCP server. All the how-to articles are structured exactly the same way and describe all the necessary steps to successfully connect to the machine with the Connectware. And that's how it basically works. If we now go back and select services, we can see that the Modbus connection is established. That means that we are connected to the machine and data is available in the MQTT format. We can now go ahead and connect the second machine for our use case. This machine is using the OPC-UA standard, so we select the OPC-UA connector in the service catalog. The service, and because we want our data to be published in the same data topic as before, we need to put as well the same name for the area ID as we did for the first machine. The machine is a different one, so we call it Milling Machine 102. We click on Install, and again, we click on Enable. We can see the resources, we click on Allow, and now we already see the service is deployed with all the resources underneath here. If we now go back to services, we can see that both services are already deployed and data is being published. We can now go and take a look into Data Explorer. Here we will see that there's a second branch which we just added for the second OPC-UA machine. In summary, both machines are now connected to the Connectware, with data being normalized and published in the data topic shop floor A. Now we can go ahead and make use of the data by creating a connection to Waylay. If we now want to create automated workflows with the help of Waylay, we simply click on Install. We need to configure the connection by putting in the host and port of the service. Most importantly, we need to specify what data topic we want to subscribe. In our case, it is shop floor A. This is where the data from both machines is being published. Click on Install and then enable the service again. The service is now enabled and there's no deviation. Here on the right, we can download the commissioning file if we like. It would show us the whole configuration of the service. Now we can go back and take a look at the services. We have a Modbus connection established for the first machine and an OPC-UA connection for the second machine. All the data is normalized in MQTT and made available for use in the Waylay platform. As you can tell by the UI, we normally deploy here tens and hundreds of services in a smart factory. But for now, everything is set and we are ready to create the use cases inside the Waylay platform. At this point, I'm happy to hand over to my colleague Josh.
Hello, my name is Josh and I would like to welcome you to this second part of this promotion video between Cybus and Waylay. What you can see here on my screen is basically the admin console of Waylay, and I would like to talk you through how we act upon the data that is sent to us by Cybus through our MQTT broker, and what kind of actions we can do in Waylay and how quick and easy it is to review what is actually going on and operationalizing any analytics and logic to act upon the data. So first of all, I would like to show you how you can see the data coming in from Cybus. So we can go to settings here and then integrations, and we can see the messages that are being sent into our environment. You'll see the resource name here and some of the parameters for both the Milling Machine 101 and Milling Machine 102. We have a dashboard available as well that can show us the data. Here we see the manufacturing floor where we have a set of milling machines, including Milling Machine 1 and Milling Machine 2. And as you can see, everything is in order. We receive things like the machine status, very importantly as well, the coolant level of the coolant liquid that is being used. And one thing we have implemented here is basically a machine learning model that informs us if a prediction of this coolant level runs below a certain threshold in a time period of the next 120 seconds. So you see the time to critical coolant level here as 211. So we're expecting to be notified of that fairly soon. For the Milling Machine 102, we are collecting information around the workpiece counter as well as certain other machine parameters. And here we have implemented some logic that informs us if the workpiece counter goes above a certain threshold. And in this case, we want to take some action. So how have we done this? This is all being monitored by the instantiation of tasks. So here we have the Milling Machine 101 coolant prediction task, which is running periodically, as shown here, every 10 seconds. And what we are doing here is we're basically querying the data on a time window of 10 minutes in this case, looking at the data, we're fitting that or sending it to a machine learning model where we're fitting it according to a certain algorithm and are then getting back the time to prediction. If this falls below a certain threshold, then we are basically getting a state change from success to error. And in this case, I will be notified by a call, me being the operator of this machine. And so we are expecting to receive a call at any moment as the coolant level is running down. In addition to this, we will also raise an alarm in our system, and the operator can see that on a dashboard as well. And what we're also doing is we're storing this predicted time to target back in our database, which basically allows us to see it on the dashboard. So going back to the dashboard, this is basically the information we are seeing, and literally any moment expecting this call. The second use case around the Milling Machine 102 is being monitored in a separate task. Well, here the call is now coming. It is being read out to me. So
Message for the operator of Milling Machine 101. The cooling liquid level on Milling Machine 101 is predicted to run out in less than 120 seconds.
There you go. So this is basically the call that I have received, and I can see that an alarm has been created at this moment as well. So me as the operator, I would then be able to take action immediately on this machine. For the Milling Machine 102, we also have a task running. In this case, this is about the monitoring of something like a workpiece counter and the temperature. So in this case, we're not running this data periodically, this task, but we're acting upon incoming data. So we've got our stream of data here. I have a sensor here that checks whether the upper limit of the workpiece counter of 9,000 is being surpassed. And once this happens, I will receive an alarm here, as well as a case will be created. In this case, a third-party system. We are using Salesforce here for the demo purposes, where a case would be created. In addition to this, we're also monitoring the temperature. So this is being set as 80, the limit. And again, if the temperature of this machine goes above this, then a certain alarm will be created as well. So let's have a look at what this looks like in Salesforce. So going over here, we will see that actually a alarm has been raised, a ticket has been sent for us to check the service level agreement with our customer, my customer A, Milling Machines Inc. So this means that the workpiece counter has surpassed the threshold and an action will have to be taken. If I go back to the dashboard, I see that by now the workpiece counter is standing at 8,600. So in any second, really, we are expecting to surpass the 9,000 and then receive both an alarm here as well as a ticket to be raised. So as you can see, we have now surpassed the 9,000 threshold, meaning that an alarm has been created on this machine. I can also view those alarms on the factory floor. So I see that on the Milling Machine 101, we have an issue with the coolant level prediction low, which is a critical alarm, and that's why it's shown in red here. And for the Milling Machine 102, the service level agreement is about to be violated. So we need to take some action on this. Summing the capabilities of Waylay up, what Waylay is very good and powerful to use is to act upon different types of rules. So we can act on incoming data, implement third-party systems and solutions, microservices such as Salesforce, which we have seen here. And we can also act periodically upon certain tasks where we are doing things like using our Bringer and machine learning module, for instance, where we're doing a prediction on things like a coolant level. So this is basically the Waylay demonstration in a nutshell. I look forward to receiving any of your comments and questions through the social media. Thank you very much.
Thanks, Josh, for the presentation. So in summary, we've seen a scalable end-to-end solution made together with Waylay and Cybus. And in total, I'm very much looking forward now to your inquiries and as well for the partnership work with Waylay and especially together with Josh. Josh, do you have anything to add?
No, thank you, Danny. And thank you everyone for your attention. We're very excited to hear about your use cases. Please feel free to contact us. We have created a specific email address for this, which is cybus@waylay.io. Looking forward to hearing from you.